Okay, good morning everyone. It's a pleasure to be in front of you. Thank you very much for providing a warm welcome. How many of you enable WPA3 in your home network? Can you raise your hand if you have done? Okay, at least few people, so in that way now 6 gigahertz being opened up, probably you will basically, better I would say basically even you're using WPA today, try to enable transition or WPA3 in your home network and feel for it. So what we are doing is actually quickly recap, security. So originally when Wi-Fi came, we had web, RC4 being the encryption being used. So then couple of years time, web was broken, so industry wanted to have a solution. So that's where the IEEE started 11i, what we call robust security network. So if you want to implement security, RSN is the way to go. So now Wi-Fi Alliance basically developed a certification program we call WPA. They kept the RC4 encryption, but vulnerability of web fixed through the TKIP. But when IEEE ratified, they introduced a change. You have to implement AES as an encryption, which is mandatory. So then Wi-Fi Alliance has to update their certification program. In that way, we call WPA v2. But still, we kept RC4 for the legacy client. Fast forward 10 years, Wi-Fi Alliance was still working on the next iteration of the certification program that published in 2018, what we call WPA v3. So in the v3, they completely deprecated RC4. So we are only AES. But implementation of AES, they introduced a mode called GCMP, bit more efficient. So in that way, so any of these particular method, we have two modes of operation. So if you deploy in home, what we call personal mode implementation, and if you deploy in enterprises, you need to have authentication infrastructure, which we call enterprise scenario. So now, if you want to implement security, you have to go one of these methods. But if you want some guest Wi-Fi, we still use with no security. That was the case since Wi-Fi 1999. But to provide some comfort, Wi-Fi Alliance introduced another certification program to enhance your guest network. That's called Enhance Open. That's again certification name. Sometimes people refer to as OWE, Opportunistic Wireless Encryption. Why this is so important? When Wi-Fi 6 introduced in 2019, then lately 6 gigahertz band came. So Wi-Fi Alliance made a clear decision. So you cannot implement WPA2 in 6 gigahertz. In that way, if you are enabling 6 gigahertz band, you cannot bring any of legacy security. So in that way, you have to basically be ready for WPA3 or OWE. And then Wi-Fi 7 came, they further tightened that security. So that means you have to support GCMP 256. So that's the highest security you can get today. But now with the multi-link operation feature, it has to support across all the band, not only 6 gigahertz band, 2.4 and 5 gigahertz. So in that way, keep that in mind. So now WPA 1, 2, and 3, one more kind of recap. So in 11N days, you can enable WPA or WPA2 in the same SSID, the difference being the encryption being used. And 11AC as well, you can do the same thing. But when it comes to Wi-Fi 6, if you have a legacy band, 2.45 gigahertz, you can configure WPA2 or WPA3, so which is the higher security method. But in 6 gigahertz, you cannot do that. You have to go with only WPA3. So that's a challenging part because you cannot enable WPA2 in 6 gigahertz. When Wi-Fi 7 came, they further tightening that we cannot use AES 128-bit. So if you want 11 BE data rate, it has to be a particular GCMP 256. So that's the only Wi-Fi 7 being supported. So Wi-Fi 8, we talked about yesterday a little bit, no idea about the security enhancement, but my gut feeling is we will still keep this GCMP 256 unless something happens within next 2 years. So now when you have different kind of encryption, cipher suite, how the client know what is you being configured. So that's basically being advertised as a sort of a cipher suite AKM or the authenticated key management AKM. So now prior to WPA3, we using the 128-bit AES, the AKM value here number 4. if it is GCMP 256, ciphers would being number 9. So now, if you are doing personal versus enterprises, so you have so many different variations. So in that way, you can see the table. So we have the personal versus enterprise separation. So AKM value 1 and 3 being the WPA2 enterprise. So if you want to enable WPA3 enterprise, AKM value 5 or 12 need to be used. So now the personal scenario, there are many different AKM value. Traditional world, we have a AKM value 2, 4, and 6. And the WPA3 world, we have AKM 8 and 9. With Wi-Fi 7, they introduce another AKM, 2 AKM, 24 and 25. In that way, this is getting complicated. So now as a client device, when AP advertising this capability, he need to decide which method to connect. So that's why sometime when you have client devices, so they will look at an element called RSN element. In the beacon frame or probe responses, this information goes. In this particular example, they said use AES 128 for broadcast multicast data, either GCMP 256 or AES for the unicast data encryption. And authenticate key management, there are 4 different values being advertised. Then client has to choose what is the highest security first, and failing that, they will fall back to the other method. So when you have more security kind of features, then IEEE introduce another element called RSN extension element to advertise these other capabilities as well. So when a client they look for this element to choose which method to connect. Now we said basically now in the personal scenario, there are many different AKM values. So then if it's a Wi-Fi 7 client, they have to pick AKM 24, 25. If they fail, they can go back to the AKM 8 or 9. So like that, there are 7 different AKM value being available for personal environment. But in the enterprise environment, bit simple. You don't have that many AKM. That's the one thing why enterprise deployment is bit more success compared to the personal one. So in here, you have a fast transition enable AKM 3. If not, you go to WPA3 kind of AKM, AKM value 5. Failing that, you will fall back to AKM value 1. So now, just to summarize in that way, basically now, when we have now Wi-Fi 7, Wi-Fi 6, Wi-Fi 5 client, we have a good idea what are the interoperability issues. In that way, Wi-Fi Alliance, when they're testing their devices for client connectivity or getting certification, they have already documented some of these compatibility issues. So one issue being, a client does not like to see more than 1 AKM. If you have an old WPA2 client, they will like to see 1 AKM value. When they see more than 1, they are failing to connect. Another one is sometimes when you are advertising more than 2 AKM. In the personal scenario, you have to advertise more than 2 because there are so many different AKM available. In that way, you will see some client, not all the client, not like to join that SSID when they see more than 2 AKM. And sometimes more than 1 cipher suite being advertised, some older client does not like to join. So sometimes some interesting problems, like sometimes client device should declare what is their genuine capability. But sometimes when clients see the beacon frame, they see the RSN element, they simply copy that value and tell AP, hey, I am supporting your setting. But subsequently connection fail because that's not the genuine capability. So in that way, some of these kind of issues, like RSN extension element we talk about, sometimes client does not supporting that in the 4-way handshake and client will fail in that scenario. So like that, industry experiencing some compatibility issues when we are advertising multiple AKM. Okay? So now as a whole, now solution point of view, you can implement higher security. That means personal only mode, enterprise only mode, or enhance only mode. But then the drawback is you cannot bring your WPA2 client to that SSID. In that way, they introduce a transition mode for all of these things. But the problem in the transition mode is there are so many AKM, so many multiple cipher suite, some client get confused and they will not connect. In that sense, in the Wi-Fi Alliance specification 3.4, they introduce a mode called compatibility mode for the personal scenario. But in the enterprise scenario, no complexity, they leave like that. So that way you have to decide transition only or compatibility mode is what you are going to implement. So now let's quickly look at what are the different options available in the personal, like your home network kind of scenario. If you want to implement WPA3, you can enable either AKM, pretty much AKM8 or AKM24. If you want to support Wi-Fi 7, AKM24 need to be enabled. So that means all the band, you enable those two AKM, and you are supporting 128-bit CCMP and 256 GCMP, you are good. You can't bring any legacy AKM value. The problem in this particular method, you have to forget about WPA2 client. But if you want to bring WPA2 client, you have to bring a transition mode. Transition mode means you are advertising a legacy AKM and newer AKM on the same SSID. But in this example, we said 6 GHz not going to work like that way. 6 GHz you can't bring legacy AKM. In that way, 6 GHz you have to enable AKM 8 or 24. But 2.45 GHz you can advertise multiple AKM and multiple cipher suite. But the challenge we talk about, small portion of WPA2 client not happy with this. They will not connect. Okay? In that way, what is the way around? That's where the compatibility mode comes. So now compatibility mode, they use some feature called RSN override. That means in the RSN element, you don't advertise multiple AKM. You advertise only the WPA2 AKM, one cipher suite, one AKM. In that way, all your legacy client will be happy because they don't see that multiple AKM, they won't get confused. But then how do the WPA3 client know this SSID configured for higher security? You need to look for override element. You know, like you can see here, this particular packet capture. Actually, I need to thank one engineer from the Candela network, gave this because right at the moment, not all vendors supporting this and even Wireshark not interpreting this element as a RSN override element. In that way, the compatibility mode we talk about, so sometime it will take time to widely adapt it. But at least to know this is the solution. In that way, WPA3 client, they will not look at the RSN element itself, they will look at the override element. And they know they need to go for the higher security. So in another way to illustrate this, so now in here you can see we only advertising AKM value 2 in the 2.45 GHz. That means the legacy AKM value. But 6 GHz we can't advertise that because it is not supporting legacy AKM. We are advertising AKM 8, which is WPA3 personal. So in this environment, legacy client will be connect, no problem. They will only see a one AKM, one cipher suite. But when the WPA3 client come, they have to look for this override element. And then they need to connect to WPA3 personal. But if you bring a Wi-Fi 7 client, there's an override 2 element is there, which advertising the AKM24, GCMP 256 support. In that way, they will connect using AKM24. So now, just to summarize, in the personal deployment, you have a choice of either doing WPA2 personal transition or WPA3 personal compatibility mode. So what it will address, let's example you go with the personal transition mode. Then you have to address multiple AKM, multiple cipher suite. And then you will face this problem. Some of your older client may have connectivity issues. So then choice is to go with the compatibility mode. So then we basically, those clients will connect without any problem. But there's a slight drawback of this compatibility mode. If your WP3 client, if he does not support RSN override, he has to go with what advertised in the RSN element, which is WPA2. So then he will basically downgrade it to WPA2. So you have to decide. If you have control over your client base, I would say go with the transition mode. You can control your client. But like education, universities, we don't have any control over client devices. So if your problem is some client complaining they can't connect, if you want to address that, then you have to go with the compatibility mode. Then there are a bit of risk. Some WPA3 client will downgrade to WPA2 if they don't support RSN override. In that way, just keep that in mind. Both options are valid, but you have to assess in your environment. So now, what other challenges can come because of this multiple AKM? So example, if you have a multiple generation access point, Wi-Fi 7, 6, 5, if you want to refresh your Wi-Fi access point, if you bring some couple of Wi-Fi 7 access point and mix with other generation access point, then sometimes if your client connecting Wi-Fi 7, they go with GCMP 256, AKM 24. But if you are roaming to an old access point, he may not support GCMP 256 and AKM 24. That will need a renegotiation. That will be a disruption to the roam. In that way, cross AKM roaming to be avoided. How you avoid? Don't plan mixing different generation AP. If you plan for Wi-Fi 7 or Wi-Fi 6E, just make sure deploy one area, one type of generation access point. Don't mix different generation access point. That will result in this kind of cross-roaming issues. For the enterprise scenario, like again, there are not much of complexity. So if you really want the highest security, they have a mode called 190-bit mode. This is pretty much like a defense-sensitive environment where you want some security for like quantum resistance. In that way, you can implement this 190-bit mode. You have to use EAP TLS, certificate-based only. Higher security, you can go with that, but this is not what we are deploying in enterprises. If you are in that kind of segment, you can go with that. Only one AKM, GCMP 256. So that's what, but again, WPA2 client cannot connect. In a typical enterprises, if you want to implement WPA3 enterprise, we only enable AKM 5. But again, no legacy AKM, client has to support WPA3 enterprise. But now if you want to get a transition mode, we have to enable AKM 5 and AKM 1. Still 2 AKM, but most of the client will work with this scenario. There are not many complexity. In that way, if you want to implement transition mode in the enterprise scenario, that works well. Like universities, most of the places, 6 GHz available, they're already using this today. In that way, much success in this kind of enterprise scenario because of the not a lot of permutation. In that way, client cannot get confused like that. In that way, but again, 6 GHz in here, you cannot enable legacy AKM, AKM value 5, but in the 2.45 GHz, you can enable these two. But when it comes to Wi-Fi 7, again, you have to go with the AKM 5 with GCMP 256 only. So in that way, enterprise scenario, quite simple, probably not much problem. But if you are enabling personal mode, you have to make a choice, especially if you have personal mode SSID in your enterprise. In your home network, no problem, you can manage that, but enterprises, most of the organization, still keep this personal kind of SSID. So my general recommendation is, even you don't have 6 GHz today, start enable transition mode kind of WPA3 and see which client failing. And then if it is a limited number of client, try to upgrade the client or fix the client. But if you're getting a 5-10% of client failure, you have to go with the compatibility mode to address that in the personal scenario. So where this information you can basically refer these two documents, both released February this year, Wi-Fi Alliance WPA3 specification and the technical note. They have a lot of things listed there. In the client point of view, what are things you should avoid? In that way, these are the two references my presentation. Once again, thank you very much. Hopefully you get some idea in this particular talk.
Thank you. Excellent presentation. So we have time for questions. Please put up your hand. Mic runners will come to you. If there are other hands, please just put up your hand and somebody will give you the mic.
So this RSN override, is it something for the transition mode, kind of?
Yeah, it is specifically for the WPA3 personal transition mode, just to avoid legacy client getting confused, Okay. In that way, this is mainly targeting for the personal mode, WPA3.
So here PMF will be the optional, correct?
PMF?
PMF. For WPA2,
yeah, if it is a PMF transition mode, always PMF is optional.
Correct.
If a client is capable of WPA3, they have to negotiate.
So only we will get 1 AKM instead of the 2 AKM previously we were
getting. In the RSN correct, yeah. element, we only advertising 1 AKM. But we are having an additional element called RSN override.
Yeah.
So WPA3 client will understand that element. Legacy client will not bothered about that element.
And from the station point of view, they should support only till the WPA3, so they will able to connect with the both. Correct.
Yes, from the station point of view, no difference. Yes. If a client station is WPA2, they only look at the RSN element and rest of the thing forgetting. But if a client is WPA3, they're supposed to look at the RSN override element.
Correct.
That's the understanding.
Thank you.
Yeah.
Yeah, hi, this is Satish. Regarding WPA3, so if you are trying to connect a client, so it takes long time for a connection. What is the issue? So
WPA3 personal or enterprise? So
personal.
Personal, only difference is the frame point of view. There are two additional authentication frame. If it's time consuming, only possibilities like either encryption, like a higher encryption being used, processing or something like that, but genuinely it should not take additional number of frame point of view. They are taking additional 2 frames. Instead of 2 authentication frame, WPA3 personal require 4 authentication frame. That should not introduce significant delay. If it is taking time, think about encryption being higher, maybe taking some processing time. Ideally should not take additional time like that, should not be slowed down.
If you change the CAKM or cipher suit, whether it will improve?
If you go to the higher encryption, sometime, like processing point of view, if your client device is not able to, process that kind of higher encryption, that can slow down, but otherwise, WPA3 should not slow down,
Okay, and coming
Sorry, maybe one person is waiting, so maybe after we finish, we'll come back to you. Okay, go ahead.
One more question.
Quick.
Yeah, right.
We want to give everybody a chance.
Yeah, right.
Okay?
Right.
Yeah, quick.
So, and this supports WPA3 supports on all mode BG and older generation, or it will be only with the.
So any client device manufactured after 2019 will support WPA3 personal. But sometime if a client manufactured before that, it's up to the client vendor to go and backport the support. But sometime we anticipated they may not support it. That's the problem going to transit mode as well. They may not fixing that. In that way, if a client is manufactured lately, 2019 beyond, will support definitely WPA3 personal. Even client is 11 AC, he's supposed to support WPA3 personal. That's Wi-Fi Alliance point of view. So they won't get certification pass unless they support WPA3 personal.
Last question, please keep it to one question.
Yeah, the question is, we had the vulnerability in Wi-Fi 2 and we came up with Wi-Fi 3. And how much success the Wi-Fi 3 has provided? Or there is there any chance that we need another Wi-Fi 4 protocol to address that?
Okay, I think even though Wi-Fi WPA3 came 2018, it's now 7 years, Probably I got the percentage hand, maybe 2%, 3% in here. So that's the challenge, it will take at least 5-10 years to get a standard. So now WPA3 point of view, they will not keep it static. They will add every year, they will optimize that. In that way now 3.5 is the specification. In that way, WPA4 will not come, I would say, at least next 5 years maybe. So in that way.
Sorry. I understand, but in the interest of time, we'll take it offline.
Any vulnerability come, they will incorporate into specification. If a device being tested next year, that will be tested for additional tests. In that way, at least things get improved.
Thank you.
Thank you very much.
Yes, thank you, Rasika. Give him a big hand, please.